maneuvers that the aircraft went through when the pitch-up occurred. I will share with you the various words that were said at the time during the maneuver. And so that when you watch the videotape, you can be thinking of the words. About the time the aircraft started to pitch up, there was a transmission from the cockpit that said, "What weight?" And I think if you read this, that word will fit in because they were discussing the weight from a previous test point. As the aircraft came up to its approximately 70-degree pitch attitude, the chase called, "Hey Doug, have you got it?" The reply was no. However, at that time, the nose came down on the aircraft, and the comment was, "We are trying to come out of it now, maybe." The chase, after the aircraft then started a slicing rotation to about 90 degrees. The chase said, "How are you doing, Doug?" And about that time, the aircraft was in about a 170-degree complete turn. I don't know yet. We may have to punch it. We have to punch. The last transmissions from the aircraft prior to capsule separation. Now, may I have the videotape, please? On the videotape, you will also see a radar altitude, which is a above ground level readout. The aircraft started its maneuver at 4,200 feet above the ground. The impact area is about 2,200 feet, so they were nominally 6,400 feet MSL, mean sea level, whenever the maneuver began. This is the pitch up. About the time he said, "What weight?" The chase asks him if he's got it. He says no, but then he said maybe. We're trying to come out of it. The aircraft, you can see, is unstable and yaw and roll. It starts a right slicing maneuver. You'll notice that the altitude is rapidly decreasing. The chase asks him again. He says, think we have to punch, we have to punch. They bailed out. The capsule separated from the aircraft at 1,515 feet above the ground. Next slide, please. Now, I would like to share with you the facts surrounding these two questions. Why did the B-1 depart controlled flight? And why did the crew escape module fail to function properly? Slide, please. Now, I would like to discuss with you the center of gravity fuel control system on the B-1. This panel, which is located on the co-pilot side of the B-1 cockpit, or within easy visual access of the pilot on the left side, looks like this. This particular switch can be set in one of two positions, the switch on the CG mode panel. If that switch is set in the normal position, these two markers that you see on the vertical index system are tabbed forward and aft. They are the forward and aft limits, CG, center of gravity limits of the aircraft. And let me just tell you what the center of gravity is. The center of gravity is that point on the aircraft where all the apparent weight is seems to be. In other words, if I was to balance the aircraft and could get it balanced, don't want to drop it on the floor, that would be the center of gravity of that aircraft. That's where the weight vector is on the aircraft. Now, back to this slide. With this switch in the normal position, these two markers, two indices, locate themselves according to the aircraft configuration. So if the wings are 55 degrees back, those indices would be located something like that. If the wings were 15 degrees, those indices would move towards the top of the vertical indicator to indicate a more forward allowable center of gravity. There are two other indexes on this particular instrument. One is called the target center of gravity. If this switch is set in the normal position, the configuration is center of gravity for a particular configuration is automatically set, and the target center of gravity will be locate itself between these two indexes to make sure the center of gravity is in the proper place between the forward and aft limits. The target center of gravity, which indicates how the fuel is being transferred between tank 1 and tank 4, then moves to match the target indication, which then gives the pilot the ability to look over there and say, I've got my CG set at the proper place, and the fuel is transferring to drive my actual CG to match my target center of gravity. Now, the other position of this switch is called set, and that is the position that the switch was in whenever the accident occurred. When that switch is in the set position, this knob is enabled. In other words, putting that switch in set, selecting this to 45%, then drives the target center of gravity bug, as you see here, to 45%, with the forward and aft limits still being established automatically depending on the aircraft configuration in terms of wing sweep, gear, and flaps. The target center of gravity, as I said, is set. The actual center of gravity, the fuel transfer, then moves to put this bug opposite the target at 45%. This was the configuration that the panel was in prior to the departure. I should say on the last test point prior to departure. Now I'm going to show you a picture that was taken of the cockpit in the capsule after the accident, which shows, put it up please. Thank you. Very good. Which shows the switch in the set position, which enables the select knob. This knob in 45%. The gear, flaps, and slats had been lowered, which told the forward and aft indexes that this was the allowable center of gravity limit. However, because this knob was left in 45%, instead of being changed to the test point of 21%, the center of gravity remained at some 45 to 46%, and it was at that point at the time of the accident. You will note that the maximum aft center of gravity limit allowable for this particular configuration, wings forward, gear, flaps, and slats, is 21%. If you do a little subtraction, you will see the center of gravity was some 45% aft of its max allowable aft limit. Next slide, please. Now, what does this mean in terms of stability of the aircraft? I explained to you before what the center of gravity is in an aircraft. That's this point right here, where all the apparent weight is located, the balance point. For the test point before the departure occurred, as I explained before, was 55 degrees wing sweep, 45% center of gravity, which was the aft limit, allowable limit for that particular configuration, with the center of gravity located here. With the center of gravity at 45% and the center of gravity at 45% and the wing sweep at 55%, that put the center of lift, the lift concentrated on the wings, that lift vector was behind the center of gravity. And what this means in aerodynamics is that if for some reason that aircraft would be upset with a slight pitch up, this force right here would provide a restoring moment to bring the aircraft back to its trim condition of level flight. And that is a stable aircraft, controllable flight. Next slide, please. Now, the situation, remember, that existed, they went from a 55-degree aft wing sweep to a 15-degree wing sweep, which meant that as the wings came forward, that center of lift associated with the wings also came forward. Remember, they left the center of gravity at 45%, which meant that the lift vector was shifted ahead of the center of gravity, the weight vector. The center of gravity should have been located at this point right here. What that means is that as the aircraft slowed down, the nose came up. However, there was no restoring force, as I showed you on the last slide, to return it to the level trim condition, and the aircraft pitched up into the 70 degrees that you saw on the videotape. Next slide, please. And the facts surrounding the first question that was on an earlier slide is shown here. And I will have a set of these slides for each and every one of you after the briefing, so you don't need to take time to copy down what's on the slide right now. Next slide, please. Why did the crew escape module fail to function properly? We know now why the aircraft departed controlled flight. Now we need to explore the facts surrounding why the crew module did not operate properly. Next slide, please. This is the normal ejection sequence of the crew module. The crew module, after the ejection is initiated, separates from the aircraft. It comes up to a point where 2 drogue chutes are deployed. The reason for the 2 drogue chutes is to then pull out the 3 main chutes. The 3 main chutes are in a trail position. You can see the attach points at the rear of the capsule. The chutes fully deploy. They remain attached to the aft portion of the capsule until the capsule swings down, slows down, and then those attach points, which are attached to explosive bolts separate, and those risers then shift so that the canopies are over the crew escape module, and the module then is able to land on its impact bags to take up the shock. Next slide, please. This is an artist's depiction of what happened when the capsule hit the ground. The explosive bolt located on the left rear corner of the capsule did not operate properly. Consequently, that riser stayed attached to the capsule. What this did was put the capsule into a down, right nose down position, so when the capsule impacted the earth, it impacted on the co-pilot, Mr. Benefield's side. I'll let you look at that for a moment, and I have a videotape that I'd like to show to you. And the videotape is set up so that you will see, and it's done from a rocket sled test down at Holloman Air Force Base. It's done in complete real-time motion so you can see how the capsule and chutes are to operate. Then I will have it done again in slow motion so you will be able to see the repositioning that takes place and get a better feel for the function of the 2 bolts on the rear of the capsule. You can leave that slide up there, please, and bring up the videotape. We've left the sled track, and you'll see it better in the next one. This is the down, nose down position. See how it was attached? They overran the tape on me. I would like to take that from the top again, that tape, please. I think it's important for these people to be able to see the complete sequence. Al, would you help them?
She said it's a good
Excuse me, ladies and gentlemen. Sir? Yes, cameraman, I'm sorry, I forgot to tell you, probably better late than never though, that I have copies of that entire videotape that you will be able to use, so you don't have to focus your cameras on it.
Can I ask you to move the mic from the foot so your face is in the light?
Why, sure.
We're standing in the dark.
They were supposed to take this out of here one.
Well, that's not exactly what I meant.
Well, I know. Okay, here's this sled going down the track. You'll see the capsule initiation. You see the drogues came out. The main chutes are out. Nose down position. There is the repositioning. You see the impact bags underneath. And now you see it land. Now, we'll take it again and we'll do it in slow motion so you'll be able to observe the repositioning. Same as you saw before. Okay, now we'll stop in slow motion. The capsule is starting to rotate. And if you look at the slide and look back here, you'll see this is essentially the configuration that the capsule was in with the 3 chutes deployed when it hit the ground. Watch for the repositioning. Both explosive bolts fire. The chutes reposition. And the capsule is level and will now be able to land on its impact bag. Video off, please. Slide, please. This is my final slide. It gives you the facts surrounding the question